today's lesson is on the laws of logarithms. Just like when we operate with exponential numbers, we need to follow the exponent properties, the exponent laws. When we operate with logarithmic numbers, we have to follow the logarithmic properties and logarithmic laws. So far, we have seen the logarithmic properties. There is 3 of them. So the first one is the log with base a of 1 equals 0. The log with base a of a to the x equals x. A number a raised to the power of log ax is x. So these are the 3 log properties. We also looked at the change of the base formula, which is a must-memorize formula, which states that the log with base a of number b can be changed to log b divided by log a, providing that these 2 logs will have the same base. So, the last one. So today we're looking at the laws of logarithms. So just to recall again, the laws of exponents are a to the power of x multiplied by a to the power of y, that's a product law, is a to the x plus y. The next quotient law, we have a to the power of x divided by a to the power of y is a to the power x minus y, so we subtract exponents. And the last but not least, a to the power of x to the power of y equals a to the power of x y, so the power law. So the laws of logarithm actually are listed down below here. They're pretty much similar and connected. We can see the pattern and the connection with the laws of exponents. So if we have the log with base a of x, y, then that's the product of 2 exponential numbers. Remember, that's the spot of the exponential numbers. That would be equal to the log with base a of x plus the log with base a of y. So you can look at it this way. The exponent with base a of the product of 2 exponential numbers equals the sum of the exponents of each term in the product, right? So here we go. We're going to start proving actually the laws one at a time. So we're going with the first one first. And we call it, just like with exponent laws, the product law, but for logarithms. So how do we prove this theorem? Now, what we are going to do is we're going to let the log with base a of x be some number m. And the log with base a of y be some number n. Okay, so if m equals the log with base a of x, then we're going to say that a to the power of m equals x. Now, if n equals log with base a of y, then we're going to say that a to the power of n must equal y. And if these 2 are true, then we can say also that the product x times y must equal a to the m times a to the n, or even better, a to the power of m plus n. So we are going to rewrite the same equation that we have where we were given here. So this one here. And instead of log with base a of x, y, now we're going to write log with base a. So again, instead of x, y, we're going to write a to the power of m plus n. So I'm going to highlight them actually here. All right. Okay. So So we're going to write a to the power of m plus n. So on the other side, we had log with base a of x. Instead of log with base a of x, we are going to write log with base a. So what was x equal to? Well, we said that x was a to the power of m. So we're writing here a to the power of m plus, now instead of log of with base a of y, now we'll write instead of y the a to the power of n, and we're going to rewrite log a again instead of y, a to the power of n. So from here it's kind of easy for us to see where we're going. You can tell that here we have a log property we can easily follow. So this whole term equals m plus n. And on this side here we have these two simplify, and here these two simplify to give m plus n. So left side equals the right side here, which tells us that this equation right here is true, so that makes it allowed. I'm going to write it down here. We're going to say that log with base a of xy equals log with base a of x plus log with base a of y. Okay, so the next property actually, which is the next law, which is what we call the quotient law. It's easier to prove if we go over the power law first. So I'm going to move on to the power law, which is the third one for today. So what is happening here? So what we have here is log with base a of x to the power of r equals r log with base a of x. So in this case, what we are going to do is we're going to let log with base a of x, this term right here, equals some number m. Okay, so log with base a of x equals m. So what that means is that a to the power of m would equal x. Now if a to the power of m equals x, then x to the power of r must equal a to the power of m to the power of r. And just to highlight this here, so this is a to the power m, a to the power m, so that's x. So, and we're going to rewrite this equation again here with our new terms. So instead of log ax, we're going to write log with base a of a to the power of m to the power of r equals r. And then we have log with base a of x, log with base a of x. But what did we say x was? So x was a to the m. So we'll write a to the m instead. So let's do some simplifying by using properties. So we're going to say this 2 will give just the exponent, this 2 will just give the exponent there, and we end up with the product mr in one side and equals r times m in here. So mr, rm are the same. We're going to say left side equals right side, which kind of proves very nicely what we were trying to here, right? Now, when it comes to the quotient rule or quotient law, we're going to say that it's kind of easy to prove it by combining. Let me just separate that. By combining the power and the product law. So here we go again. We're going to say log with base a of x to the y can be seen as log with base a of x times y to the power negative 1. According to the product law, this would be log with base a of x plus log with base a of y to the negative 1. So the first term doesn't change, but the second term in here has an exponent. This exponent can come to the front, and we have plus negative 1 log with base a of y. So we're going to say that log with base a of x over y equals log with base a of x minus log with base a of y. And that's how we prove the quotient law. Now we're going to practice a few examples. So example number 1a says we have log with base 3 of 6 plus log with base 3 of 4.5. So in this case we have bases the same. Remember, just like with exponential numbers, the bases in logarithmic numbers must be the same for the two numbers to operate together. So we're going to rewrite this using the product law as log with base 3 of 6 times 4.5. So that would equal log with base 3 of, that's 24 plus 3, so that's 27. Even better, log with base 3 of 3 to the power of 3. And again, we're going to say the answer here is 3. So we're talking about this number 3 in here. Okay, and next question. It's an application of the quotient law. We have log with base 2 of 48 minus log with base 2 of 3. So that equals log with base 2 of 48 divided by 3. So that's log with base 2 of 16. Log with base 2 of 2 to the 4. And according to the second property of laws, then that would equal simply 4. Next question. We have log with base 5 of third root of 25. So I'm going to rewrite this as log with base 5. 25 can be the same as, or written as 5 squared, everything to the power of 1 over 3. So that's log with base 5 of 5 to the power of 2/3, and that would equal 2/3. Okay, last question. This would actually, just to talk a little bit about this, it's an application of the log properties, but it can also be looked at the power law. So you can take the 1/3 right at the front here, and then you can continue working with the rest of the expression. So the number works out nicely. That's why the property can be enough for us to prove it. So the next question is log with base 3 of 9 to the power 1/3. I'm going to go the longer way a little bit here. It's the same way, but so just trying to show how I'm using the power law. So the 1 over 3 that is in the exponent here can come to the front. And that's 1/3 log with base 3 of 3 squared. And that's where we get 2/3. Okay, so moving on to the next page, we have a few more practice questions we want to work with. Log with base 7 of 30 plus log with base 7 of 10. And here we have log 7, 30, times 10. That's log 7, 300. Now the question in this case is just asking to express as a single log, so that means we're done here. The next question is log with base, a log of 12 plus half log 7 minus log 2. So there are more terms in here, nothing to worry. So what we focus on first is the bases. So are the bases the same? Well, I don't see a base here. That means the base is 10. I don't see a base here, means the base is 10. Don't see a base here, it's 10. So that means all bases are the same in every log term. So there is 3 log terms. The next thing that we need to take care of is we don't want to have coefficients, because coefficients means power law, and power law or exponents apply first. Remember bad math. It works in a funny way here though. So we're going to rewrite this first as log of 12 plus log of 7 to the power of half minus log of 2. Now I'm going to combine together these two, and that will give us log of 12, and then the plus means that we are multiplying these two numbers. Sorry. And this minus in here indicates that we are dividing by number 2. So in a simpler form, this would be log, the 12th and the 2 will give 6, and then 7 to power 1 over 2, that's root 7. So that's the answer, log of 6 root 7. Next. Now, notice that this time we don't deal with numbers inside log, we are dealing with expressions. So we're gonna check the bases. The bases are same, the bases are 3. And we have log with base 3 of x squared minus 1. We have subtraction here, that means that we are dividing the terms. X plus 1, plus 1. Now we want to simplify here. And we're going to say that's log with base 3 of x plus 1, x minus 1 over x plus 1. And you notice right away that you can simplify these two terms. And that would equal log with base 3 of x minus 1. Now, one thing we shouldn't forget in here, we must emphasize that we have removed a denominator. So for whatever happens, x cannot equal -1 then, right? So the next example actually deals with using the properties of log to express each logarithm in terms of either log ax or log ay. So this is called simplifying, sort of to speak, expanding we're expanding the logs, but we want to expand it in terms of these two smaller terms. So we have log with base 6 of x squared y cubed. So it means we have a product that we need to deal with first, and that's log with base 6 of x squared, and then plus log with base 6 of y cubed. Now, since we want to express only in terms of log ax and log ay, we don't have just log base x, log base y, we have powers as well, so we need to take care of them too. So that would be 2 log 6x plus 3 log 6y. Next question. Log with base 2 of the 4th root of a divided by bc. So quite a few things going on here. We have division, we have this product, we have a power. So we're going to break this down slowly. So we have log with base 2, and then we have the fourth root of a, and then minus log with base 2 of BC. Okay, now this is a product right here. So that would equal log with base 2 of a to the power 1/4 minus, now remember you have a product here, you need brackets. So that's log with base 2 of b plus log with base 2 of c. So in this term we need to take care of the power because we just want to have a right in here, and that means we have to write 1/4 log with base 2 of a minus log base 2b minus log base 2c. Okay, so this is one way of dealing with this. Another one, which can be seen as an easier approach for many of you, is this. I'm going to have to erase this part here. You can also express this expression inside log as a product, the whole thing. So what's going to happen is we're going to have here log with base 2 of a power 1/4, b power -1, c power -1. Okay, and now we're just dealing with the log of the product. So that would equal log with base 2 of a to the 1/4, and then plus, because it's a product, log with base 2 of b to -1, and then plus again, oopsie, log with base 2 of c to the -1. So we have 1/4, so we're applying the powers now in every term. So let me highlight them very quickly for you. So we have one power here, and a power here, right? And 1/4 log with base 2 of a minus log with base 2 of b minus log with base 2 of c. So the terms that we see in here are only log with some base of a variable, log with some base of another variable, log with some base of another variable as well. Okay, so next example. Again, if you want to, you can try on your own. You can just stop the video, and you're going to have some practice as well from the textbook. So next question is log with base a of, now you see how we have a power here of 1/2 represented by this square root, and this power applies to every part of the expression inside the root. So what I'm going to do is I'm going to apply the power first. So we have x to the power of 3 to the power of 1/2, and then we have y to the power 2 to the power of 1/2, and we have w, since to the power of -1, since we're writing it as a product, then we are bringing a negative exponent in here to power 1/2. So we have the product rule throughout. So that means we are applying the product law. So that's log with base a of x to the power 3 over 2 plus log with base a of y squared to the power of 1 over 2. I can do the power right away. So power of 1. And then plus log with base a of w to the negative half. So that would be 3 over 2 log ax plus 1 log ay minus half log aw. Okay. I don't know if you can hear my son in the background. It is quite annoying and it's distracting. He's playing Roblox with his friends. Okay, moving on to the next example. We have log with base a x3 root y over z squared. Same strategy. I'm going to write every term inside the log in product form. It's easier to operate that way. So we have base of a, and then x to the power 3, y to the power 1/2, z to the negative 2. So we have product everywhere. And we have log with base a of x to the 3 plus log with base a of y to 1/2 plus log with base a of z to negative 2. So multiplications here turn into additions, right? And that would be 3 log ax plus 1/2 log a y minus 2 log a z. That's the answer. So we have expressed every term in terms of some log, some base x, some base, and then y, some base z. Now, in the last example, we have to rewrite the expressions given as single logs. The purpose is just to apply the log laws that we just learned. So the thing that I want to pay attention to are, number 1, the bases. They must be the same for the numbers to agree with each other and combine, be able to combine. And the next thing you want to look at is what operation do you have in between. So we have minuses. That means that we have the quotient law here to apply, and there are again different ways of doing this. I'm going to try to first show you one way that I think it's easier. So remember how we expressed the previous example is all the expressions inside the log in product form. So we can do something similar here if you wish. So we can rewrite it as log x squared minus 1, and then instead of minus we write plus log, the base is a everywhere, x plus 1 to the power of negative 1, and then plus again log with base a of x minus 1 to the power of negative 1. So these negative signs in here, right, are becoming the negative powers in here. So now that we have pluses everywhere, then we're going to say there is one law that applies in here throughout the expression. So we have log with base a of x squared minus 1 times x plus 1 to the negative 1 times x minus 1 to the negative 1. Now that we know the powers are negative, we can rewrite this with positive powers as x squared minus 1 over x plus 1, x minus 1. So that would equal log with base a of x plus 1, x minus 1 over x plus 1, x minus 1, surprise, surprise. So we see that, sorry, that would be log with base a of number 1. Even better, this is 0 actually. Okay, so the last example. In the last example, again, we have to check the bases. They're a everywhere. We have to check with the exponents, right? So the coefficients, right? The coefficients are the exponents and vice versa. And you probably want to make the minuses into pluses by bringing this minus in, let's say this minus in as a power. Okay, so I can write these three. I will write these three things on the side. So check the base. So what do you check? You check base, check. It's the same. Number 2, coefficients, check. The coefficients must be in, right? Bases must be same. And last thing is negative coefficients. Bring them in, but this is optional, right? So if you have a negative coefficient, bring it in so that you can have only one law to apply throughout the expression. So here we go. We're going to check the bases. They're all the same. All bases are a. So coefficients, they must be brought in. So we're going to write log with base a of x squared minus 1 to the power of 1/3. And then negative, change to positive, log with base a of y to the negative 1. And then plus log with base a of z to the negative 4. So now that I know that all the signs between terms are positive, then I'm going to say that we have log with base a of x squared minus 1 to the power 1/3 multiplied by log with base a of y to the negative 1. I'm sorry, gosh. That's times y to the negative 1. And then times z to the negative 4. So we have log with base a again. Since we know that we have some negative powers, we need to bring them down. So we're going to have a rational expression to deal with. So x squared minus 1 to the power of 1/3. And then down here we have y to the power 1, z to the power of 4. So that's a single logarithm. So that was today's lesson. And please complete your homework as indicated on your handout.